So yes, so Cathal and I thought it would be a really nice venue to give a presentation of our recent paper on concept utility, discussing some further aspects, also explaining some motivations for the paper. So let me see if I can. Okay. So here's a puzzle about concepts. The paper is in part about how we constitute concepts, and part of the paper is about how we come to revise our concepts. And as is well known from a host of examples in the literature, including so examples from biology to astronomy in the history of the sciences, we sometimes revise our concepts, and it seems that some taxonomies are better than others. So one example, of course, is the case of whale being reassigned from the category of fish to mammal by Linnaeus. A more recent example is the reassignment of Pluto from the category planet to a new category of trans-Neptunian objects. So often these changes suggest we were mistaken, or we might have been mistaken, since there remains usually some controversies about the best way to categorize an environment. Now, the standard theories of concepts we think are not adequately equipped to explain conceptual revision. So this paper is really a proposal to account for optimal concept constitution and then for conceptual revision. Let me say something about the background. So one line about concepts is, let's say, the family of internalist views on which, let's say, the concept horse may be defined in terms of some particular description, like the things that whinny, that race at Cheltenham, that stamp their feet, have manes, long tails. There's a variety of theories of concepts, which ranging from descriptivism to theory of concepts, which may be seen as falling on the side of an internalist picture of concept. And on those views, it's not necessarily clear how we come to revise concepts. You could say that maybe we come up with new prototypes, but then we need an account of how, let's say, prototypes or best representations come to evolve. What kind of pressure do they put on concept revision? This is not something that is really part of the theory. Then there comes social externalism, on which, let's say, a horse may be defined as that thing that experts use the word horse to refer to. So work by Burge and Chalmers illustrates the view. There, I think a difficulty is, although we can be mistaken about the expert use, the experts themselves can conclude they were mistaken. And so we also need an account of basically how the experts come to revise their concepts. And the third kind of view is natural kind externalism, on which a horse may be defined as the set of things that share their essence or intrinsic nature with that X, where X is a particular instance of the category. And as I was just mentioning, even experts actually can be mistaken about natural boundaries. And the view on which categories are defined in terms of intrinsic nature or essence does not really say how we decide where the natural boundary lies. So we're trying to address these issues in the paper. And the goals really are to characterize the betterness of conceptual schemes. And also, the way we do this is by proposing a measure of what we call the epistemic utility of concepts, concept utility. It's basically a pragmatic account in terms of a combined measure. And in the next section, Cathal will actually explain this background to the theory, so the epistemic utility view of concepts. And then he will deploy the theory in terms of a framework in which objects and properties are sort of two driving forces behind concept revision. And I'll take over then explaining how concept revision might work in general. And in the paper, we illustrate this with a case of the revision of the concept planet. We think this is not just a sort of anecdotal example, but an example that is more telling of the deep underlying structure of concept revision in general.
Great. Okay, so what we wanted to do was to construct a theory of concept utility out of the components of epistemic utility theories. And so in essence, the question of why you'd revise a concept has to hinge at some point on the question, what makes one new concept better than the old one, or what makes a new conceptual scheme better than the old one? And so we wanted to ask in general, what makes a concept useful? And of course, we use concepts to form beliefs. Sort of the job description of a concept is to act as the atoms or the components of beliefs. So if you believe that the cat is on the mat, then you're entertaining a thought, or you're committing to a belief in which the concepts cat and mat and sat appear. And so perhaps we thought if we start looking at the question, what makes a belief useful, we could derive from that account a theory of what might make our concepts useful in terms of epistemic utility. So what makes a belief useful? Well, there's one obvious candidate. Oh, I can make this bigger, can't I? This will be better. Is that better?
Yeah, that's better.
Okay, sorry. Okay. So one thing that will make a belief useful is if it's plausible. So and you could think of this in evolutionary psychology terms. If you want to catch the deer, you want to have a true belief about where the deer is. That's going to allow you to catch the deer. And if you have false beliefs about where the deer are, you're not going to catch the deer. So one thing that we want our beliefs to do is to be true, captured in this phrase by Bernard Williams, that belief aims at truth. But as various people have pointed out, plausibility or likelihood of being true cannot be their only usefulness for us, cannot be the only thing that we want them to do. If, for example, let's think about that for a second. So if you wanted to maximize the plausibility of your beliefs, one way to do that would be to adopt nothing but tautologies as beliefs. So you could believe that one is one, and that birds are birds, and fish are fish, and you'd be guaranteed that all of your beliefs will be maximally plausible. But that doesn't seem like a very helpful way to go around the world. Even though you have maximally plausible beliefs, they don't seem to be perhaps doing very much for you. And here's a nice illustration of this issue from Patrick Maher's book, Betting on Theories. So he talks about, he quotes a conclusion that Cavendish drew about experiments he had carried out on the electrostatic force. And the conclusion that Cavendish accepted was, after all, he did all these experiments, was that the electrostatic force falls off as the nth power of the distance for some n between 1.98 and 2.02. So he gathered up all of this evidence, thought it was very strong, and he made this estimation of this particular measurement. And then Maher points out, okay, sure, he drew that conclusion, but of course, if he wanted to have an even more reliable conclusion, he could have just made it less specific and said, well, the electrostatic, if it falls off between 1.98 and 2.02, if he has evidence for that, then he has even stronger evidence that it falls off as the nth power of the distance for some n between 1 and 3. And of course, that's, he can increase his margins of error, and by doing so, he increases the plausibility of his conclusions, or he could just conclude that it falls off as the nth power of the distance for some value. And then he's got a much more plausible conclusion still. And then Maher asks the question, why doesn't he draw these obviously more plausible conclusions? Why is he restricting himself to something that's less plausible? And the obvious answer is because those more plausible conclusions don't tell you very much about the world. In fact, the more plausible they become, the less they tell you. So we also want our beliefs to be informative, and this is something, actually Franz Hubert's paper has been a huge help to us in thinking about this, called the plausibility informativeness theory of belief, I think. And also you can connect this work with the work of Karl Popper, who talks about the fact that we want to have falsifiable theories. It's something I always thought was very puzzling until I realized that, oh, well, the more informative a theory is, the more falsifiable it is. So the more it tells you about the world, the easier it is to find a phenomenon that falsifies it. So it's not really falsifiability. What Popper was interested in, it was informativeness. So, okay, we also want our beliefs to be informative. Now, interestingly, these two features of belief go in opposite directions. So generally, the more informative your belief is, the less plausible it's going to be. If you put forward some hypothesis that concerns the whole world on the basis of one piece of evidence, its plausibility is a lot less than if you put forward that hypothesis just concerning some narrow domain. For example, if you see that bluebirds lay blue eggs, if you see a bluebird lay a blue egg, and then you conclude that bluebirds lay blue eggs, well, that's reasonably plausible. If you conclude that all birds lay blue eggs, that's more informative, but now less plausible, because you're extending this observation you've made to a bigger domain. If you conclude that all animals lay blue eggs, you're coming up with a more and more informative claim, but it's getting less and less plausible. So they tend to push in opposite directions. Another way to think about this is in terms of, let's say, a roll of a dice. So if you say that you roll a dice and you make a prediction, or somebody tells you that it's going to be a 1. So the plausibility of the claim is going to be 1 in 6, obviously. But elegantly, you can say that you can characterize the informativeness of the claim in exactly the same terms, and it turns out to be some sort of an inversion of the plausibility. So if the claim is that it'll be a 1, well, that rules out 5 out of the 6 possibilities. So you could give it an informativeness measure of 5 out of 6. And what is the 5 out of 6 is, of course, also the probability of the negation of the same hypothesis. So if the plausibility that the hypothesis is it'll be a 1, and the probability of that, the plausibility of that is 1 in 6, well, the informativeness is just the probability of the claim that will be false. So of the negation of the hypothesis. So what's the probability of the claim that it won't be a 1 is 5 out of 6. So there's this really elegant symmetry between informativeness and plausibility. And like I said, they seem to go in opposite directions. So which should we prefer? Supposing we want our beliefs to be informative and plausible, well, should we prefer the beliefs that are more informative or the beliefs that are more plausible, since they are actually going in different directions? And one reasonable thing to think is that we adopt beliefs that are informative enough for our purposes given the context. So, that meet our needs for plausibility in a given context. So, for example, if you're in a scientific context where you only want to make claims that are extremely plausible, you will restrict the informativeness of your claims, and you'll only adopt those claims that, let's say, have a plausibility such that the null hypothesis or the negation of the hypothesis has been reduced to a likelihood of 0.05 according to the scientific conventions. But if you're in a more casual context and you don't really care about having extremely reliable beliefs and you're more concerned about having informative beliefs, let's say that somebody's asking you if berries are good to eat, and you say, yeah, sure, berries are good to eat, berries are good for you. Now, strictly speaking, there might be a lot of berries that are poisonous, but generally, when you're living in a city, let's say, most of the berries that you're going to find are in shops, and they're the ones that are already good for you. So it's much more useful to just say, yeah, berries are good for you, berries are good to eat. It's not extremely reliable as a claim, but under the circumstances, it's more informative. Okay, so supposing that we care in general about informativeness and plausibility in our beliefs, and that in general we're looking for some sort of a trade-off between the two, maybe striking a balance between them. What's interesting to note now is that you can see how informativeness and plausibility vary with, we think, with two measurable features of concepts. And throughout, we're thinking of concepts really as categories. So rather than as mental representations, we're thinking of the mental representations as doing the work of categorizing the world. So we're really just thinking of them in terms of the categories. And what we want to say is that there are two features of these categories that can be identified and measured, and that co-vary with the informativeness and plausibility of the beliefs that we end up using those concepts to form. The first is that informativeness can increase with the inclusiveness of a concept. So if you observe a bluebird laying a blue egg, and you draw a generalization from that belief, bluebirds lay blue eggs, that has some level of informativeness. But if you now make a generalization over a concept or a category with greater inclusiveness, like all birds lay blue eggs as opposed to just bluebirds, that's clearly more informative. And of course, if you extend it to all animals lay blue eggs, etc., the informativeness increases. So informativeness seems to go up when the concept is in the subject position in a universe of generalization like this, as the inclusiveness of the concept increases. And by inclusiveness, we simply mean that some concept C is more inclusive than another concept D if C is a superset of D, so it contains more objects. And we're going to think about these generally in terms of objects and properties, which we'll talk about in a minute. And if that's the case, then a generalization over C will be more informative than a generalization over D. It's simply going to tell you about more things in the world. So that's the first connection that we want to make between inclusiveness and informativeness. And there are some wrinkles there which you might have spotted, including that the concept has to appear in the subject position in a universal generalization. But we can talk about that later. So for example, yeah, just as I said, all whales eat krill is more informative than blue whales eat krill, and the concept whales is more inclusive than the concept blue whales. So that's so much for the connection between one property of concepts, namely inclusiveness, and one property that we care about in our beliefs, namely informativeness. So a second property that we care about is plausibility, and we think that this can also co-vary level of belief, a property of concepts, namely the homogeneity of a concept. So let's say that some concept C is more homogeneous than D if the members of C have more features in common than D. So if the concept or category blue whales, its members share, let's say, all of their properties in common. In that case, the concept or category blue whales is more homogeneous than the concept whales, because there are other whales outside of the set of blue whales that have properties that blue whales don't, and so on. And as the concept expands to cover more and more things, generally the homogeneity is going to go down. And so a generalization over C from an observation of one of its members, so you see a blue whale produce a water spout, and you think blue whales produce water spouts. Well, if you use that category to make a generalization over the restricted category or concept blue whales, that will be more plausible than if you make the generalization over a much bigger concept, like whales, or like all animals, etc. So homogeneity, we think, co-varies with the plausibility of the generalizations that you're going to be in a position to make. So whales eat krill is less plausible than blue whales eat krill on the basis of just the observation of one blue whale eating krill, let's say. And the category whales is less homogeneous than the category blue whales, and that seems to be straightforward as the explanation for why it's less plausible. So, assuming that these two properties of concepts co-vary with these two properties of beliefs, this, we think, provides us with a way, if you start to measure those properties of concepts, to decide maybe what concept within a taxonomy to use for a generalization depending on your needs for plausibility. So if you're writing a scientific paper and you make an observation of a blue bird laying a blue egg, you don't make a claim like all birds lay blue eggs, but you restrict it to something much more plausible. So it might tell you which concept to use for a given task on a particular day. But it might also tell you, and this is where we think this can do work of explaining how domains are conceptualized, it could also tell us how to conceptualize a domain in the first place, so how to carve a domain up into distinct categories. Okay, so this brings us to this next section, where we think about domains as collections of objects and properties. And we try to come up with measurements for the inclusiveness and the homogeneity of the concepts and also collections of concepts. So if we think of an environment, by the way, can you see the whole slide, or are there little videos of people in front of you? You can see the whole slide, so you can see the numbers on the right, yeah? Okay. So let's suppose we think of an environment as a matrix of objects and properties, and properties could be also thought of as equivalent to just features in some of the discussions of this issue. So you could have three objects. Let's say the first object has all of the properties F1, F2, F3. The second one has the second and third properties. And the third object has just the first property but lacks the second two. Well, and you could imagine that this is some domain of objects you encounter. So you have a killer whale, a shark, and a sperm whale. But of course, you don't know how these things are supposed to be categorized together. You're not sure which one goes with which. The killer whale has a spout, and so does the sperm whale. But it has a dorsal fin, and so does the shark, and the sperm whale does not. And the killer whale has an aerodynamic shape, as does the shark, but the sperm whale less so. So, and if this is all the information you have about these three objects, you've got this question, okay, how do I carve these up? So, you could, for example, think that you could come up with several ways of conceptualizing or categorizing the group. So you could think of them as all belonging to just one category, a single concept, we're going to say. Or you could think of them as belonging to two categories. You think that the killer whale and the shark go together because they seem to be superficially more similar. And you think of the sperm whale as being a different kind of creature, belongs to a different category. Or you could put the shark and the sperm whale together and think of the killer whale as falling under a different category. Or you could put the first and the third together and give the shark its own category, or you could just have three different concepts altogether. So how do you make a principled decision? Well, so we think that if you start measuring the homogeneity and inclusiveness of concepts, you can put these measurements together to give you an answer to this question. So let's imagine that we think of the three creatures as falling under just one category. So the first concept to evaluate is a concept that includes all three objects, C, O1, 2, and 3. How do you measure inclusiveness? Well, inclusiveness of the concept is just how many objects in the domain fall under the concept. In this case, everything. So the inclusiveness gets a measure of 1. Our measurement for homogeneity goes as follows. So you say for each feature, how many of the objects in the domain have the feature? So for the first feature, 2/3 of the objects have it. For the second feature, 2/3 of the objects have it. And for the third feature, 2/3 of the objects have it, right? Now, let's imagine you had just two creatures, then it will always be the case that the minimum value for that estimation, that measurement, will be a half, because either they both have the property or neither of them have the property, in which case they'd get a value of 1 in each case. Or one of them has it and the other one doesn't, in which case you get a value of half. So we rescaled this measurement just to give us a broader scope and a measurement that goes from 0 to 1. And so each time we evaluate a feature, we rescale it by 2x minus 1. And so we multiply it by 2n minus 1, subtract 1, and then so 2/3 becomes a third. So 2/3 by 2 is 4/3 minus 1 is 1/3. So that we use that little trick to rescale the features. And the second and third features get the same value. And then you sum them and get an average, and you get a value for the concept that the homogeneity is a third. Okay, and then you can say, since we value both inclusiveness and homogeneity, just as we're going to value informativeness and plausibility, then you can simply multiply these values by each other to get a joint value for the two features, or the two virtues of a concept. And in this case, it's going to be 1 by a third, which is a third. So then you can think of this partition. And a partition in this case is just the same as the concept, but if you have multiple concepts, the partition would be the whole collection of concepts. And to get that value, you average the utility of each concept. In this case, there's only one concept, so you're dividing the value here, a third, by 1, and you still get a third. Okay, so that's thought of as under one concept. So now imagine it's two concepts. We'll take one example of this, which would be if you group the shark and the killer whale. The first concept, C1, groups together objects 1 and 2, and the second concept covers object 3. The inclusiveness of C1 is 2/3. That's obvious. The inclusiveness of C2 is 1/3. Now the homogeneity of C1, you do the same thing. You get half for the first feature, 1 for the second feature, and 1 for the third feature. A half by 2 minus 1 is 0, and the other values by 2 minus 1 ends up being 1. So you end up with 1 plus 1 plus 0 over 3 equals 2/3 as a measure of the homogeneity of the first concept, and 1 plus 1 plus 1 for the second concept, because a concept with just member is going to be perfectly homogeneous. So then you get a utility measure for the first concept, which is again the inclusiveness by the homogeneity, which in this case is 2/3 by 2/3, so 4/9. And for the second concept, a third by 1, which is a third. And then now you can talk about a utility measure for the partition, which is the average of the utility of the concepts. There's two concepts, 4/9 plus a third, and then you divide them by 2. Sorry, there's a symbol missing there, and you get 7/18. Okay, and now you get an interesting result. So, okay, now we have some way of measuring, saying why, actually, in this case, if this is all you knew about these creatures, you could measurably say that you should split the group into two concepts rather than lumping them together under just one category. Okay, so interim conclusion, and now I'm going to hand it over to Paul, that the informativeness and the plausibility of our beliefs is directly affected by the inclusiveness and the homogeneity of our concepts, and we can measure these, and this can produce this way of optimizing our conceptualization of a domain.
So now we're on to concept revision. Cathal really introduced the main ingredients to the procedure we're going to describe. So if we think of concepts in terms of epistemic utility, we now have a score of inclusiveness for a concept, a score of homogeneity relative to a set of features. And the main idea is basically that we revise concepts essentially based on the discovery of either new properties or new features, or on the discovery of new objects. So these really are the sort of two driving forces, as I was calling them, behind concept revision. And we can illustrate this with the following example. So we have our 3C creatures, as we had initially, the 3 features you're familiar with, having a spout, dorsal fin, aerodynamic shape. And I'll assume that, you know, we sort of take account of this other feature having mammary glands. So we see that's only some of these creatures have the feature in question. And you can see where this is going, right? So now the same 2 creatures give live birth. They also, so one of them has gills, but the other 2 do not. So you can see that as we're adding features, the basically criteria for either lumping or separation of the objects into categories divert from what we had before. And in this case, so here's an example in which initially, so we could think that, you know, lumping orca with shark was actually meaningful. Leaving whales into a separate category. If you calculate the epistemic utility of the partition, in this case, you get a score using the same machinery that Cathal was explaining, which is lower than the one you get if you group if you group orca and whale together. And this is not surprising because, as you could see, the addition of the new features is basically giving us more reason to group the 2 individuals together and just separate out the shark into a separate category. Now, if you now think of keeping the set of features constant, there's also some effect of just discovering new objects. Initially we had just 1 orca. In this case, we have 3. You see that this creates a lot of homogeneity, of course, between the various representatives of the same species, in this case, of the same, which was initially sort of infimum species. And as you can expect, the category you get by just grouping the 4 individuals on the left-hand side is, I think there might be a mistake here, because basically...
no, that's right.
Is that right? Okay, yeah. Sorry, Cathal. Thanks for correcting. Okay, so in this case, yeah, this is a case, there's only one odd one out right here. So that's indeed right. So despite the fact that the shark has only a single feature in common with the killer whale here, namely the aerodynamic shape, you can see that the utility of the left-hand side grouping concept is 2/3, and it's the partition on the right-hand side gets a utility of 1/2. Basically, homogeneity is at maximum in each of the concepts on the right-hand side, but the inclusiveness, is not the same. So when you average, you get this epistemic utility of 1/2. And now this is where I was getting at, right? In this case, grouping is more beneficial than just separating the individuals into 2 categories. Now, if you keep adding individuals, so discovery of a second member of the shark population, this will, of course, change your score of inclusiveness. And the same is going to happen if you add more individuals, of course. And in this case, as you can imagine, you get basically pressure towards separating the two categories. So we can look at that. In this case, if you kept grouping together the individuals, what happens is relative to each of the features, we now have minimum homogeneity, in each of the features. Although we have maximum inclusiveness on the left-hand side, whereas on the right-hand side, we really strike the right balance between perfect homogeneity in the features and this sort of half inclusiveness. So when you do the calculations, the partition on the right-hand side is still at the utility of 1/2 versus 1/3 for the partition on the left. So basically, we lowered the score we had initially when there was a single member of the shark population in this case, which is why in this case the taxonomy on the left-hand side just loses to the one on the right-hand side. Okay, so what you see, we can assign concepts a score of epistemic utility based on inclusiveness and homogeneity. We can assign partitions epistemic utility based on how they carve out concepts. And the scores we get allow us to define a preference ordering on the conceptual schemes. And finally, we can explain why some schemes get to be revised with the discovery of either new objects and new properties, which I would say, in spite of criticisms made to theories of concepts which work with features in the background, we think having features in the background is actually a virtue of the account. But we can come back to that in the Q&A. So now I'd like to come to what was actually a motivating example behind the project. It was one of the motivating examples, but it's a sort of a salient example. You find it discussed in the paper. It concerns the demotion of Pluto from the category planet. As you may know, so Pluto was discovered in 1930. Back then, the astronomers decided that it should be grouped with the other representatives of the category planet in our solar system, extending the category planet from 8 to 9 objects. Despite that, it's very instructive to see that as early as 1930, specialized articles in astronomy journals, for instance, this paper by Frederick Leonard, The New Planet Pluto, they characterize Pluto as an oddball in the category, just the way the shark was an oddball in the initial comparison with the 3 killer whales. In particular, it is known now. It is better known that Pluto has a tilted orbit. If you compare the orbiting plane of Pluto to the ecliptic plane of the other planets. It also has further sort of odd features. We know that it's much more distant from the sun. It has this icy structure, and yet it didn't quite occur back then to be able to split the planet in the planet category into 2 subcategories. So that's the first observation, which we think can be used to buttress the previous toy example we gave in the case of sea creatures and conceptual revision, or non-revision in this case. And actually, if you do a bit of history of a recent history of science, it's very interesting to see the way in which this case of concept revision happened. Alan Stern and Stern-Levison, in a paper from 2000, wrote about the criteria for planethood and proposed planetary classification schemes. Their paper is really fascinating because the way the paper begins is actually very reminiscent of the way in which, let's say, Roche and Mervis talk about the alleged impossibility of defining concepts on the basis of criterial definitions. So basically, what Stern and Levison point out, what exactly Roche and Mervis pointed out in their 1975 paper. Given the list of planets that we know, each supposed criterion is going to come out with an exception. So, for instance, presence of satellites omits Mercury and Venus, can be time dependent. Presence of an atmosphere nominally omits Mercury. presence of a magnetic field on its Venus and perhaps Pluto. And you see a number of other features. I'm not going to read through them all. But what is interesting is the conclusion. We find that no single criterion can adequately define the conditions for planethood. So you could think, well, actually, what they should be doing now is do an analysis based on typicality features and maybe just give up on having criteria for planethood. And it's not what they're doing. What they suggest is actually to look at two criteria for planethood. One is a criterion, they call it geological criterion, and the other one is called I think by now it's called a geophysical criterion, the first one. The other is a dynamical criterion. And the second one is actually very close to what the International Astronomical Union kept as the idea of clearing the neighborhood around its orbit for a celestial body to be called a planet. And by both criteria, so the Pluto is actually a planet, a bona fide planet. By the second criterion, on their account, Pluto is what they call an unterplanet, so close to what by now is called a dwarf planet, using IAU terminology. But interestingly, by 2000, Pluto was still a planet according to those astronomers, because despite having odd features, it had the other main features, so orbit, shape, and the geological criterion, right, is basically being round in shape. Now, what's happened is that between 2000 and 2005, a set of new celestial bodies were discovered. In particular, in 2003, Eris, whose official discovery was announced in 2005, sorry. It's a Pluto-like object, roughly the size of Pluto, with very similar properties. And so when Mike Brown discovered it, he thought, did I discover the 10th planet? So this is this story is well told and really exciting in his book, the one we were mentioning, How I Killed Pluto. It turns out that there's a host of arguments to classify Pluto and Eris, first of all, in the different regions of the solar system, the so-called Kuiper belt, which is pretty much to what the giant planets, it is to the giant planets what the asteroid belt is to the terrestrial planets. So it's actually packed with objects. They haven't cleared the neighborhood around their orbits. And now we can look at the way in which the revision may or may not happen. So look at the situation in, let's say, 2000, just relative to the criterion that Stern and Levison had just identified, namely the dynamical criterion, clearing the orbit around the body in question. So Pluto fails to have a criterion. So if you just look at the utility of just making Pluto a category of its own, in fact, even just looking at this criterion, the concept on the left, right, which groups all the celestial bodies together, is going to give higher utility compared to the split partition with two concepts on the right-hand side. On the other hand, by 2005, so now there comes a list of celestial bodies which are planet-like, most of them discovered by Mike Brown and his team. So now you see that the homogeneity relative to the criterion is going to decrease if we keep all the elements together. And indeed, we get higher utility now if we just split the category into two concepts instead of just keeping us to a single concept of planet. And the question was actually, fiercely debated around 2005 when the IAU announced the resolution of demoting Pluto from the category planet. It is still debated. Interestingly, Stern-Levison believe in the geophysical criterion over the dynamical criterion, but that's a separate story. We can talk about that in the Q&A. So I come to the conclusion now, which is that what Cathal and I presented is basically a measure of what we call concept utility. Cathal explained the way in which this notion of concept utility is derived from the more familiar notions of plausibility and informativeness in the field of epistemic utility more generally. We see that these two measures of inclusiveness and homogeneity can be used to rationalize concept revision. And we also see the sense in which some recent examples, some actual examples of concept revision, like the case of Planet in the sciences, can be rationalized in terms of our measure. Basically, there remain some problems which we can talk about. Here, we assume, right, that all features receive equal weight. We haven't really accounted for the way in which the features get selected or weighted. So those two questions remain to be discussed. The accounts could be modified to assign different weights to different properties, of course. As you see, it's a very flexible framework. Of course, it relates to other, statistical frameworks dealing with clustering. So in a sense, it's flexible in the same way. And as I mentioned, in the case of the Stern-Levison criterion, one of the criteria was given less weight than other properties in 2000, possibly more weight after the discovery of more Pluto-like bodies. So I would say, I don't know if Cathal, you would agree, but I would say that an element of theory, right, remains behind the selection of features in this case. We're not just working blindly with features being given. Then there has to be an account of the way features get to be selected and weighted. But there remain perspectives for this framework, for this approach. One is just maybe Cathal can talk about that in the Q&A. We have a more sophisticated account in the paper of not just dealing with single concepts or flat taxonomies with just a single partition, but nested partitions, so hierarchical taxonomies. The second thing is the approach we think may be used to account for this interesting notion of basic level category that Rush was emphasizing, Rush and others, Rips and Mervis and others in their work in the 70s. Namely a category for which the description comes out as natural, more natural than for superordinate or subordinate. And the final point is something maybe we'll discuss in the Q&A. You may think that our approach does more work than we claim. That we have a recipe for to exclude ties in terms of competing taxonomies, and it's actually not the case. So we're happy to come back to this point in the discussion. But in a sense, I would conclude with the message that the approach is more, although it's one side to it is still driven by externalistic considerations. We hope to strike the right balance between internalistic and externalistic considerations, and so we don't rule out the possibility of a plurality of optimal taxonomies. And I think it's a good point to stop. Thanks very much.